This is the first demonstration you're going to give with the Aruba demo kit. At this point, your presentation should have introduced RF management. That includes ARM, Adaptive Radio Management, and the RF Live planning and visualization tool that's included with the controller. So we're going to go ahead and log into the controller for the first time. In all instances, the password for everything is Aruba #2 demo. So just keep that in mind. The only places in this demonstration where that will differ is with the phones and with the cameras. And we'll talk about that in a later section. When you hit the screen, you should spend some time explaining kind of what's going on here. So we have WLAN network status. It shows our controller status, that we have 2 access points up, one of which is a mesh portal and one is a mesh point, and that we have an error monitor up. We can also come around to the other sections. Interfering APs detected. We've seen 86 total, 45 in the last hour, 13 in the last 5 minutes. And down here we can also see the interfering clients. 15 total, 14 last hour, 7 in the last 5 minutes. Later we'll take a look at rogue AP classification and summary when we plug in our rogue access point. Right now what we're going to talk about is AP setup, ARM, and the RF planning tool. So what you want to do up at the top is click on the planning tool, and that's going to take us to our RF plan. Now you should generally only have one main campus and one building in that campus, and hopefully you've drug your APs to the appropriate location or a room that's similar. What we'll go through is a little bit about what this tool gives our customers. So the first thing is building specifications. We can come in and dimension our buildings, and we can choose models for both our AP and AM. Now this helps us when we go into the planning tool. So we can select floors and then down to floor 1, and we'll see what's actually on the floor right now, but we can also go into an AP planning mode where the system will go through and suggest and initialize an AP plan and an AM plan based on the square footage of the floor and the selections we made up in the modeling of how much coverage we want and what types of APs we're using. In this instance we've already deployed, so we can come down and take a look at the floor. Now we're already seeing a heat map generated even though this network has only been up for a few minutes. Down here in the detail, we can actually take a look at the different AP types we have and where they're located on the axis, what AP type they are. We'll see their wired MAC address, IP address, and we can see their channel and power settings. Now right away you're already seeing in the BG space where ARM has taken effect. So for the 2 different access points, it's selected channel 11 and 1, and they have 2 different power settings on those 2 APs. Now in this particular instance, because we're using mesh, you'll see mesh point and mesh portal back here, and they're both on 48 and 30, and that's the backhaul channel we're using to move data from our mesh point to our mesh portal. So ARM will not use that particular setup. You'll need to explain that because you won't see that change, whereas the channel and power settings often will fluctuate even during a demonstration, especially with no clients attached. Now we're going to zoom in and take a look at what our map is actually showing us. You may need to zoom in greater than 500%. Right now the channel is selected to all. You can go to all merged and see everything together, or you can go back to all separate and see the different channel power settings. You can do AP coverage, you can do AM coverage, and you can do AP for BG coverage. What you should not do is AP for 802.11a coverage, and that's simply because the 11a is not actually providing coverage. That's used strictly for the mesh backhaul. If you want to cut it down, you can also cut your speed down to show a particular coverage rate. So right now this is where the system believes we're getting 54 megabits coverage in this particular building based on what it can hear. Now you'll see this kind of seashell shape going on, and what that is the system's actually drawing what it can hear, but it's not drawing the pieces it can't hear, so it becomes more predictive on this outer edge where we have no other APs listening. If we had additional APs out here, we would actually see more realistic speeds. We might see some spikiness as interference occurs and does not occur, and based on where our APs are located. This is also why AP placement on the map is important. So when your customers are installing their APs, they need to make sure they're as close as possible on this diagram to where they are in reality. As they hover over, you can see the different coverage. We'll see what kind of power settings we have, what channel settings we have, and this is for each device. If we change this to layered data rates and you hover over the data rates, we'll tell you what each one of these circles is based on what we have drawn out. So each color has, or each ring has a different setup, and each color is a different channel. So that concludes our RF Live and ARM presentation. What your customer should be left with, and you should reiterate, is that ARM takes care of channel and power settings so that the customer does not have to, and it reacts to interference sources by automatically changing power and settings. This is much different than any single channel plan you'll hear about, and it's different than most other automatic settings in that it can keep scanning and it knows what the client status is, so it knows when to pause scanning so that it doesn't disrupt client communication such as voice. We also provide tools needed to visualize the network and see what's actually happening in real time without separate appliances, and we can help with planning with a built-in tool to do automatic site surveys.